Hey everybody, this is number 55 from the review. This is using Gaussian or row echelon form for a 3 by 3. That's a 3 equation, 3 unknown matrices setup for the systems of equations. So wanted to just do a quick little video for you because this one can be laborsome, but I wanted you guys to try it on your own first. So that's why I didn't go over it in the group quiz. So without further ado, here we go. Let's see if we can work through this. Remember, this is just one way to do it. You can do it any way you want, substitution, elimination, but this is a way to kind of like our synthetic division, get rid of the variables and just focus in on the coefficients, all while making sure that we understand where the variables are and what each of those rows, columns represent. Okay, so first thing, notice that we have our x's, y's, and z's all in a row, along with our equal sign and our constants on the other side. So when we rewrite this, I'm going to go ahead and do an exchange for our row 1 and row 2 while I write these things down. So I'm going to put my brackets, and I'm going to call this my row 1, and I'm going to take all of the coefficients of those variables. So a +1, +1, -2, and then we're going to draw a vertical line to represent the two sides of our equation, and that would be equal to 12 on the other. Okay, then I'm going to go ahead and call this bottom one here row 2, which would be a 3, 1, -1, and 10, and then the top one here row 3, 3, -2, 1, and -7. Again, this is just one way to do it. You could have kept them how they were given to you. Whatever process that you end up doing is completely up to you. Just remember, what we want is actually what we currently have. Unfortunately, it won't stay that way, but we have our diagonal of 1s, and with the row echelon or Gaussian elimination, we want everything below it to be a 0. In reduced row echelon or Gauss-Jordan, we want the upper half of our diagonal to also be zeros. Because if we have that, then we know that this would be our z, this would be our y, and this would be our x. Whatever those would end up over there. Okay, so that's our goal. What we're going to do here is just Gaussian, all right, row echelon form. And the nice thing is, and this is why I rearranged this to be row 1, is I already have my 1 up here in the first slot. Okay, so I'm going to keep it like that, and then I'm going to zero this out and zero this out by doing a few steps, which we will write down. So I'm going to say I'm going to multiply a -3 times row 1, add it to row 2 to get a new row 2. So the only thing that will be changing is my row 2. So I'm going to go ahead and keep my 1, 1, -2, that equals 12. In my equation or row 1, I'm also going to keep, for now, my row 3. The only one that's going to change is my row 2, and how we're going to do it is multiplying row 1 by a -3 to everything and adding it to row 2. All right, so that will then give me a -3, a -3, a +6, and a -36. And then what I like to do is just put it right under or above, wherever there's room, and then circle and highlight what I'm going to end up changing. And that would be row 2, as we mentioned. So adding those together now, after I multiplied by -3, I will now have a new row 2 of 0, -2, 5, and -26. Now we will rinse and repeat and do something almost the exact same, because this happened to be a 3, to get the next 0. Okay, so I'm going to again take that -3 times my row 1 and add it to, this time, row 3 to get a new row 3. So I'll start by rewriting this as -3 times row 1 added to row 3 to get my new row 3. Again, that's the only thing that's going to change from this new matrix, and that will then leave me with no change in row 1. So 1, 1, negative 2, 12. No change to our new row 2, which is 0, negative 2, 5, negative 26. But there is going to be a change in our new row 3, and I'll highlight that with a darker color green, and multiplying this row 1 by negative 3, and then adding it to row 3 to get our new row 3. So that will give me a negative 3 here, negative 3 here, positive 6, and negative 36 again to give me new row 3. By adding all of these things, I get 0, negative 5, 7, and that would give me a negative 43. So we're on our way. We got that leading coefficient of 1, and then we got the zeros on the next two. Now we want to get that next thing to be a positive 1 in our diagonal. So that means I'm going to have to multiply this whole row 2 by a certain number, and that would be negative 1/2 to row 2 to get a new row 2. So again, the only thing that will be changing is my row 2, and it's going to change by a negative 1/2 to that entire row 2. So that will then leave me with taking a negative 1/2. That's the same as dividing by negative 2 to everything to get 0, positive 1, which is what we're trying to get. Unfortunately, negative 5/2 and positive 13. So we're almost there. We got our 1 and then 2 zeros. We now have our diagonal of 2 1s. Now we need to get the 0 under it before we attack this. Now one thing you cannot use is row 1 to get this to 0 out, because it would then make this not be a 0 any longer, which is what we already worked hard to get. So you actually have to go down the line or row here and use row 2 to keep the 0, but to make that a 0 as well. So we will be using row 2, and we will multiply it by a positive 5 times that row 2, and we will add it to row 3 to get a new row 3, which again means I'm not going to change row 1. I'm not going to change row 2, even though we're using it, but I am going to change row 3, and we said by multiplying row 2 by 5. So this whole thing, I'm going to multiply by a 5, and I will add it to row 3. So I'm going to write it right underneath here. So let's multiply this whole row by a 5. That will give me my new elements for that row 3 or equation 3, which we will insert here. So that leaves me with a 0, 0, which is why we did all of that. And then this one I'm going to have to go off to the side, and I'm going to have to take 7 and subtract 25/2 to it, which means I'm going to have to multiply by that fancy 1 to get 14/2, my different looking 7, minus 25/2, which gives me a negative certain number of halves. And we know 25 minus 14 to be 11. And then negative 43 plus the 65. The positive is definitely going to win that out, so we just find the difference. 65 minus 43 would be 22. And so our last step, and I do mean last, because we have our row almost of 1s and everything below it zeros, we just need to make this a 1. And how can you always make a fraction a 1? Well, that's by multiplying by its reciprocal. So we will take, for this last thing here, of our matrices, we will multiply by a negative 2/11 to row 3 to get a new and final matrix with that new row 3. So again, not changing what we have other than that row 3 that we're trying to manipulate. Remember, the reason we can do all of this is because these rows represent our original equations. And we can do whatever we want to an equation as long as we do it to everything, everything, everything. And so we're going to multiply this row 3 here by a -2/11, which will keep a 0, keep a 0. And when we take -11/2 and multiply it by -2/11, negative times negative becomes positive. Anything divided by itself is 1. So that's where we get that +1. All we still have to do is take the 22 and multiply it by -2/11. So the 11 will go into that 22 twice, and we get a -4. And that, my friends, is our finished product of what we needed and wanted as far as matrices go. We have our row of 1s and everything 0 underneath. So we now have our z, no x, no y, but just our z is equal to -4. And so once we have that, it's very easy and simple. Just be careful and know that each one of those columns represents your x, y, and z. And remember, that represents our equal sign. So right here we have z is equal to -4. And once we have that, then we go up a line and we use this next row or equation, which says 0x's, which means I don't even need that, but I got the y's and the z's. And so I know that 1y minus 5/2 of our z is equal to 13. And I put parentheses when I said z because we know our z is -4. So we will back substitute in this -4, and hopefully you can see there that this actually works out pretty well to become positive. Those cancel, and I get y plus 10 over 1 equals 13. And what plus 10 will give you 13? Hopefully you said 3. And now that we know those, we'll go one more line up, and we will use row 1, which had our x, y, and z values. And since we know 2 out of those 3, we just are going to substitute in one more time when we know that 1x plus 1y minus 2z is equal to 12. And since we know z was -4 and y was +3, then we can combine our like terms, which this becomes a +8 and 3 to get x plus 11 equals 12. And what plus 11 gives you 12? Obviously, that is a 1. And all we get to then do is put this in our answer blank, which, remember at the beginning, we had the x, y's, and z's. So we need to, since we found it, give them the ordered triple now instead of an ordered pair, because there is 3 variables. And remember, we put it in the order that we, no, not the order that we found it, but the order of the alphabet, x, comma, y, comma, z. All right, so be careful with that. We found x was 1, y was 3, and z was -4. So we will put 1, 3, -4 in parentheses for our ordered triple, which means that if we use those x, y's, and z's in equation 1, it would come out true. Equation 2 and equation 3 all would equal those numbers. And by the way, that is the only solution to this system of equations. All right, hopefully that helps. Remember, this is just one technique. Feel free to practice. Good luck on the exam. That's all I got for you right now. Take care, everyone.